For our final lecture video, we will be talking about the ballistic skill of striking. So striking actually encompasses a numerous amount of skills. It can be performed with various body parts, or you could use implements, and it could also be performed in a variety of orientations. So we have sidearm striking and overhand striking, which are discussed within the examples in this chapter, but there's also underhand striking, like in a golf swing. So very wide variety of skills that are encompassed by striking. The mechanical principles across all striking tasks are relatively the same, but developmental changes haven't really been well documented across the lifespan. So while we have this general sense of what things look like, there are potential movement patterns that we won't touch base on, just because we have a limited number of observations. Additionally, the book kind of likes to target its focus, like I said before, on sidearm and overhand striking, specifically with the use of implements, such as a bat or a club or a racket. So keep in mind, again, while general movement patterns and developmental sequences we discuss could apply to several types of striking skills, there could still be variation in skill development based on changing task constraints, kind of based on how your task goals are changing and what types of equipment you might be using. So to start us off, we'll go through developmental changes in sidearm striking first, and then we'll go through overhand or overarm striking. So sidearm striking is defined as striking in which the arm, specifically for our class, the arm or limb remains at or below shoulder level, and this involves the most perceptual judgment based on ballistic skills that we've discussed so far in this lecture series. So similar to punting, where you have some object moving in space and you have to coordinate or use that visual stimulus and information you're getting from the movement of the object with how you move your body. Same goes for sidearm striking, but because for the book chapter we're specifically talking about striking with the use of implements, we not only have the control of our body now, but we also have the control of the implement, as well as tracking any other projectile objects in our environment. So lots of perceptual judgment is needed for proficiency in these striking skills. As far as characteristics of early sidearm striking, usually we would observe some type of chopping motion, more in the vertical plane rather than a sideways plane. And then similar to our kicking and throwing examples that we've looked at so far, the movements that we see are kind of limited to the arm. So very little leg or trunk movements are supplementing this striking action. As an example, we have this cute little dude. Let's see if it looks like it wanted to play, but it's acting weird. Might have to scroll through it this way. So he has ball. And then generally we notice as he swings the racket, it's in a vertical motion instead of a sideways motion. Okay, so hopefully that plays better on your end. I don't know why it wasn't working on mine. As far as intermediate sidearm striking, usually there are some improvements to movement patterns. Typically we can see more of a sideways preparatory stance to add to the sideways motion of the arm. Typically we'll add in some type of trunk or pelvic rotation. Usually it's blocked together, so the trunk and pelvis are moving as one unit. we start to notice a little bit more lag in the implement, like racket or arm, and we also observe more sequential movements, so including the use of a small step, perhaps, or starting to move adjacent joints more independently of one another. Okay. Do have a video example of intermediate sidearm striking. Again, I don't know why. This is dumb. Alright, but you can see sideways stance in comparison to the forward-facing stance we had in our earlier sidearm striking example. He's got more of a backswing directed in a sideways direction, uses his body weight to add force to the striking movement. Okay, so improvements. And then we could further see greater proficiency in this Proficient sidearm striking example, where preparatory stance is still sideways, but there's a utilization of a longer step, so again, greater weight transfer, shifts more power into the strike. There's more differentiated trunk rotation between the upper spine and the pelvis. The horizontal swing will go through a larger range of motion with specific extension of the arm before contact. So again, kind of pointing back to our previous examples, when we're trying to maximize force, we usually will carry our arm in a flex position because it's more energetically efficient, and then toward the end of the movement pattern we'll extend the limb to maximize the velocity that gets translated into some projectile object. And then even more sequential movements than we had observed in the intermediate example. So in this image, we can see her limbs moving through a full range of motion, and there's more incorporation of leg and trunk movements to increase power. We also have a video example, and I have a feeling I might have just too many graphics in this PowerPoint that it's not liking me. But this particular example, he didn't really take that longer of a step, but I think what we can get from this is that he's got more sequential movements in his upper body, has a more coordinated use of his rotation in his body. So overall, we see a little bit more of like a smoother movement pattern in terms of the sidearm strike. For developmental changes, we do have an observation plan that we can follow, and generally speaking, these are the steps in the developmental sequence. So mainly, like, the most noticeable change in movement pattern is that the plane of swing changes from more of a vertical swinging motion to a horizontal motion. So step 1, we would say, is more of a chopping movement in which the racket is swung more up and down. Step 2 is where we have an arm swing only, where the racket swings ahead of the trunk. So racket, and then you might notice a rotation or a passive rotation of a trunk as a result of the swing. Step 3 is where we start to consider the lag with respect to a front-facing position. So if the preparatory stance is sideways, as the racket comes around, does it lag behind the trunk rotation? And for how long? So we could lag behind and then have the racket start swinging kind of in front of our body, or our moves in front of our body before front facing, which would be just step 3, or the lag could occur at or after the front facing position. The other common thing, or more notable thing, so vertical swinging versus horizontal swinging, and then the preparatory facing direction being more front facing for step 1 compared to side facing for steps 2 through 4. As I noted in our previous slides, the use of our limb, or taking advantage of our limb length and how we can manipulate that throughout the strike, becomes more sequentially utilized with more proficiency. Incorporating the lag ends up giving us more force to be translated into the ball or object that's being struck. Another thing we usually notice is how a person grips their implement. So usually we see a power grip, which is more of just like a forceful squeeze, and that transitions to what the book referred to as a shake hands grip. So there's a little bit more adaptability in how the implement can move in your hand with this type of positioning. As far as observation strategies, usually it's good to observe both from the front and the side. From the front, you can get a good sense of the direction of the step, the plane of the swing, how much arm extension is occurring. From the side, you get information about the preparatory steps that are taken, how much trunk rotation is occurring, and then the actual extent of the swing, because you can see the full range of motion across the body. For overarm striking, this is when the arm is traveling above shoulder height. So sidearm striking is at or below shoulder height, overarm is above. Okay. Similar to sidearm striking, overarm striking can be done with or without an implement. So an example without an implement might be a volleyball serve. An example with an implement could be a tennis serve, which is generally what our examples are in this chapter. So for our characteristics of early overarm striking, again, usually we have limited motion to the arm itself when we're talking about striking with the arm specifically, and there's limited trunk and pelvic rotation. You'll also notice that swinging happens with a more collapsed elbow, so that's kind of persistent throughout the different images in this figure. The arm and racket tend to swing in unison or as one unit, so there's little lag that occurs or little sequential movements that are going to be contributing to force production. And then there's also typically a low point of contact, so you can see where he contacts the ball is kind of in line with his face. That could be, just a scale thing in the drawing, but it is a good, if there wasn't a hanging ball here and it was a moving target, that's a pretty good representation of what you would observe. For proficient overarm striking, we notice more involvement of spinal and pelvic rotation, typically going from more blocked to differentiated rotation. The elbow is usually held between 90 and 119 degrees at the start of the forward motion of the strike. So again, that's kind of an optimal angle. I can't speak. That's kind of like a more optimal angle to maximize the force that's transmitted into the ball. There's also more lag, as you can see in this photo, of the arm and the racket before striking the ball. And overall, this is a more sequential and coordinated movement pattern than compared to early overarm striking characteristics. When we look at the developmental changes, most of these actions are kind of on track with overarm throwing, so some of the movement patterns or characteristics might sound a little bit familiar. What's different about these is that we split them into two phases. There's the preparatory phase and then the ball contact phase. And additionally, there's a greater focus on kind of approximated angles of various joints and rotations throughout the body. Again, it's typically best to observe overarm striking from both the side as well as behind the performer, so you get a good sense of how the implement is moving, how the person is moving, and then how all of that is working in relation to the object that is coming at them or that is hanging stationary in space. So we'll first talk about the preparatory phase and the trunk action that occurs. The sequence is as followed. So first step would be no trunk action whatsoever, so just, again, limited to arm movements. Step 2 would be minimal trunk rotation that's less than 180 degrees. Step 3 is total trunk rotation, which would be larger than 180 degrees. Again, the more range of motion you move through, the greater the arc length that your arm can go through, the greater the velocity that gets transferred into the ball. Now, I don't really know why the textbook doesn't provide any sample videos or images for overarm striking other than the ones I already showed you, but I'm kind of just going through the steps, and then if I think something doesn't sound intuitive, I'll do my best to show it to you in my limited space. But that's the preparatory phase. The rest of the actions that we look at are in the point of contact with the ball. So again, think kind of along the lines of a tennis serve where there's a ball above a person's head and they're striking it kind of using this circular motion. Okay. Step 1 would involve either very small or very large angles of the elbow, so either extending it too much, which is not efficient whatsoever, or kind of keeping the elbow tucked in to strike, as we saw in the little video earlier. For step 2, we would have a little bit more of an intermediate angle, kind of more along the smaller side. So again, kind of keeping the arm more tucked in towards the body, or more elbow flexion. And then the ideal angle would be 90 to 119 degrees of elbow flexion. So that's going to kind of optimize a person's ability to move both efficiently through the angular arc that they have to pass through, but also to get the best force transmitted into the projectile object. At ball contact, we can also look at spinal and pelvic ranges of motion, and the degrees or relative degrees for both of the upper spine and pelvis are pretty much the same. When we talk about the rotation part, spinal rotation in the book is referring to rotation at the level of the shoulders, and then the pelvis is looking at rotation below the waist. So you could also think about it as spinal representing upper trunk rotation and pelvis representing lower trunk rotation. Generally, though, we see greater amounts of rotation as we get more proficient performers. The last thing we look at in overarm striking is the racket action and how much lag there is. With more proficiency, there's more of a lag to enhance the force that's transmitted into the ball. I feel like I just keep repeating that, so I apologize if that's getting redundant, but hopefully the concept is making sense. And the way that we would describe the lag is pretty similar to the flowchart that we saw for sidearm striking. You just change the orientation of the strike to overhead instead of sideways. As far as the assessment of ballistic skills, we can use the developmental sequences from throwing punting, kicking, striking, all of these. We can use those developmental sequences as checklists to determine skill proficiency and progression with practice. So, I don't know how many of you are familiar with like Gentile's taxonomy, but by changing different task conditions, or maybe we have the same task condition, but we're just following like how complex that movement is and how coordinated a person is able to like fit that movement pattern into the task constraints, is kind of a nice way. So checklist for progression. I started getting in a tangent, so apologies. Typically, a person is classified under a certain level of development if a given characteristic is present in a majority of trials out of 5 attempts. So if we are assessing people, usually we say 5 tries, and then we see which developmental sequence step is most prevalent throughout those attempts. Obviously, keeping in mind what the task instructions are important when you're examining the worth of the classification that you end up putting somebody under. And then the other thing to keep in mind that I've already repeated it several times is that observation should be conducted from an appropriate direction so that you have a good vantage point in relation to the performer. That way you don't miss any of the critical components of their movement pattern. So typically we would view things from a side view. In most of our ballistic skills, that offers the most information about the movement patterns that we might see, but also using frontal or rear views could be beneficial for a various number of skills as well. In summary, the developmental trends in ballistic skills that were presented in this chapter are, again, generally more targeted towards goals of maximizing force and speed. So, characteristics such as taking longer preparatory steps or adding rotational movements of the trunk or pelvis, or maybe rotations that are coordinated between other adjacent body parts, incorporating lag in the extremities or in implements to increase angular displacements or velocities, etc. All of these characteristics are movement patterns that would allow a promotion of larger force production and greater projectile distance traveled, as well as producing faster movement patterns as well. So, promotion of mobility. The transition to the most efficient and proficient movement patterns is not automatic. So a lot of ballistic skills require practice and experience or sufficient exposure in order to achieve higher levels of proficiency. We also know research on ballistic skills, or the developmental trends in ballistic skills, is pretty limited, specifically in older adult populations. So it's kind of difficult to say how developmental trends are maintained or decline throughout the lifespan, but what we generally know in terms of age differences is that older adults typically maintain fairly proficient and coordinated movement patterns, and form is going to be improved with greater amounts of previous experience, but rate limiters may be more impactful on the movement patterns that emerge based on normal aging patterns or other individual constraints that could be playing a role in older adults. Another good thing to remember, or a main takeaway, is that not all people reach the highest developmental steps in each type of ballistic skill. Additionally, various components or actions within each ballistic skill tend to develop at different rates. So the arms might develop slower or faster than the legs, which I think is pretty apparent in some of the steps that we've reviewed throughout the lecture for these various skills. Lastly, the interaction between task conditions or goals and individual constraints is a fairly strong determinant for emergent movement patterns. So our examples that we've kind of commented on is like task conditions or task goals that focus on force or accuracy. In our throwing examples, we could see like there's a regression of developmental sequences when we have to throw for accuracy versus when we throw for force. And it's not necessarily a bad thing, right? Because performance could still be good with a lower proficiency classification. Other examples might be changes in target position or proximity to the individual, so changing distance demands or distance parameters, as well as target motion within the environment. So task conditions do play a pretty large role in terms of constraining the types of movement patterns and proficiency levels that you would observe in the variety of ballistic skills we discussed for this week. So that concludes our lecture videos for this week. If you have any questions on that material, please let me know.